Hi, my name is Kaushik, as Eric mentioned, and I work at Expedia. Expedia itself is a suite of popular brands, some that you might have come across, which is Expedia.com, Hotels.com, and Verbo. There are many of the brands that we have at Expedia. And over the last few years, we've been going through a transformation, which is consolidating our tech stacks. And this presentation is about our journey of how we can go towards a proactive reliability approach and delivering our software. Just a bit of context, Expedia is quite broad. We have 35 domains, which typically consists of shopping, flights, cars, payments, checkout systems, and so forth. So logical domains is what makes up Expedia as an entire entity. We have 26,000 applications at Expedia. That's a lot of microservices, a lot of services that we have, which you can imagine is quite hard to manage as a group. On that, we run 500 plus Kubernetes clusters where all these applications are deployed. We have over about 40,000 worker nodes at Expedia running on AWS, and they're in multiple regions. So we're kind of covering a lot of ground here to kind of give you an idea of the scale that we have at Expedia. As I mentioned, we were going through a consolidation of our tech stacks over the past few years. Every kind of logical domain or brand had their own potential runtime environment. They had their own observability platforms, and they also had their own service meshes, and they used to use different flavors of every little pieces of technology to get the best out of their systems. Platform engineering has been evolving recently, and there's this concept of paved roads, and this is something that we want to kind of try to approach to see how we can kind of consolidate some of the best of everything to get a developer experience as seamless as possible. The idea here was we go towards a common goal of a common platform where developers from these different brands and from these different domains can deploy their software and manage it reliably. In 2019, we ran an analysis of our current state of LAN. This is pre-COVID. We were going through our instances. We had a lot of instances from different brands. And what we noticed was with this picture on the left, that a quarter of our outages are caused by change. Now, not uncommon. Everyone kind of guessed this was going to be the case. But you can still see some other things like certificate expirations, like that still kills people, no matter how much you try to get rid of certificates and try and solve and automate that through other technologies out there, but they still knock us out. 29,000 applications, one's going to miss a certificate here or there, so it's always a problem. The thing that was quite interesting was a lot of these changes, a lot of these outages were caused by a contributing factor of change. Something had changed in the system, and that's almost 70% of our incidents were caused by a change. We've tried it before, where we reduce the changes on the weekends, or we try to reduce the changes on Christmas time when it's like change freeze, but it kept coming back. Something in the system kept changing at all times, and when you've got so many applications, it's very hard to figure out which one's causing them. On that note, what we want to do is try to figure out how to release our software safely. I'm going to hand it over to Nikos.
Thanks, Kaushik. So in the release safety space, we come across a set of strategies. The first one is the blue-green strategy, where we have two separate but identical environments. And here we have a clean switch when it comes to deploying changes to, let's say, production. However, as you can imagine, this is not very granular. It is also not very cost efficient. And this is why we also present the canary flow at the bottom. With the canary flow, in the same way canaries were sent in coal mines to detect toxic gases and prevent harming humans. We safely deploy our changes by doing canary releases. So basically having a traffic sifting stage to deploy our changes. We took into account these two strategies, and what we have implemented on our side is what we call progressive deployment. It pretty much covers these two strategies, plus adds a linear traffic shifting stage and options.
Given that we're running on Kubernetes, given that we've got a service mesh, and you explain these concepts, can you give some examples of how that traffic shifting might happen?
Yes, sure. So how does this work? Let's give an example. Imagine having an initial state where, as Kaushik mentioned, we deploy our services on Kubernetes. We use it as our service mesh. And our engineering teams deploy to multiple instances, replicas or pods in Kubernetes. As you can see in the image on the left, we have the initial state where we have, let's say, 5 pods, and our entire traffic is served by the primary deployment. Now, when we want to deploy changes to production using this progressive deployment platform, what we do is we clone the primary deployment, and we create 2 more deployments here. One is the baseline, which will be used to make a decision on whether we want to progress to production or to roll back. And the second flavor is the canary. And as you can see in this example, we have 50% of the traffic served by the primary deployment and 25% each by the canary and the baseline deployments. And like that, by comparing the metrics, we can basically make a decision, as we said.
So something that we were kind of going through our journey, which was platform engineering, like DevOps was coming through, platform engineering was coming through. What can we do to make this experience as seamless as possible for our developers? Like there's 29,000 applications. How can this be working?
For this, we have built on top of Spinnaker. We use Spinnaker as our continuous deployment and delivery platform. And we have created a custom experience, as you can see in the slide. So engineering teams can use Spinnaker to safely deploy their changes to production. And as you see in the CMODs, they also see how the deployment progresses over time. They can find useful logs or even links to the observability platforms. On top of that, they have the option to even cancel or roll back the change. And we have also done a lot of integrations with internal systems. We have integrated with notification mechanisms, with change requests and tracking platforms that we use internally, and also with observability tools and all sorts of other tools internally.
So we've got a release mechanism that works for everybody. Actually is great because it might solve a lot of our change-induced kind of problems at production. But the big thing that was happening during the time we started this experiment was how do we verify this stuff is working in production as expected? How can we actually prove that our resiliency is improving with techniques or tools? Is there anything we can do in that space, Nikos?
The reality is that nowadays, and we can all agree on that, with distributed systems, we have too many failure modes. You know, we don't just have JVM applications, we have containers, we have pods in Kubernetes, so a lot of abstractions. And this means many failure modes. For example, engineers now deploy to multiple instances, multiple replicas, and many of these teams have autoscaling in place. Autoscaling can be, again, implemented at different levels. And they might want to verify their autoscaling mechanisms. They should also be able to understand, but also tolerate any disruptions. And in general, they need to be prepared for incidents.
You use the word prepared. That's interesting because a lot of engineers have to prepare for a lot of things, be it writing best code, be it deploying the software, be it monitoring it. We have a managed platform. We have a CI/CD process that we can kind of utilize. Can we utilize this technique that you're referring to for our developers and make their lives easier?
In a similar way to our progressive deployment platform, we have built an internal chaos engineering platform, which is now provided as an end-to-end solution to our engineers in the company. And the architecture looks as follows. Our engineers can go to Spinnaker, our CD tool. They can select the target and the experiment. As an example, let's say that as an engineer, I want to block connectivity between 2 pods, X and Y, running in the same cluster. This request then flows through our control plane. We have a control plane to propagate any changes in what we call worker clusters. And once we filter down the target to the worker cluster, we have this agent, the chaos controller, which is an open source solution by Datadog, that will pick up this request and inject the failure into the infrastructure. As you can see here, it will be injecting an infrastructure failure on the target container so that we block connectivity between these 2 pods.
Sounds great, but I'm a manager, I'm a leader, and this sounds scary. How do you protect the system from being misused, or How do I stop and freeze what's happening?
Again, we provide a similar experience with a progressive deployment platform. We have integrated with Spinnaker, and this means that, again, engineers can see the progress of any experiment, they can find useful logs, they can find links to observability platforms, and on top of that, there are plenty of safety nets we have implemented here. One is the popular big red button. At any point of time, an engineer can click this stop disruption, and the disruption will be immediately canceled. And then we have a lot of additional safety nets that are at the controller level. For example, the controller works by using Kubernetes labels for target selection. There are limits on these labels. There are limits on the impact, even on the duration of an experiment.
So it's great to see that we've covered the cluster. As I mentioned, we also have multiple regions. Now, a cluster can be failing for a bad config or a bad rollout or a bad upgrade. And also, services themselves might fail within those clusters. Is there anything we can do in that space around a region kind of level domain of failure to help our engineers actually verify the resiliency at a region level?
As Kaushik correctly pointed out, we have covered failure modes up to the level of doing availability zone failures pretty much. So we rely on this chaos controller for any failures, and this controller supports network failures, state failures such as container failures, but also availability zone failures. It does not go beyond that though. The limit is a cluster. We didn't have a solution with that for region failures. And this is why we built the next platform. We call this region failover as a service. This platform covers three main use cases. The first one is the cluster local use case, where we have two applications, application A connecting or talking to application B within the same cluster. And for those who are familiar with Kubernetes, this usually happens through the Kubernetes namespace and the service name. Now imagine that there is an issue with application B and we want to fail it over to the other region, region 2 of the same cluster. The communication then will be happening as follows. We use the egress of cluster X in region 1, and then the traffic goes through the ingress of cluster X in the other region. This was the first use case. The second use case is the cross-cluster communication. What we have here is, again, application C in cluster Y, region 1, calling application A, which is now in a different cluster. And we want to fail over application A in the second region of that cluster. Very similar way, we use the egress of the first cluster and the ingress of the second cluster here to divert traffic. And the third use case is very common for us, unfortunately, because we still have a lot of applications in legacy platforms, and not part even not deployed even in Kubernetes. And to achieve a solution here, all this traffic goes through the DNS. So what we do here is we just redirect at the DNS level.
So again, I'm a bit worried here. Cross-region calls are quite expensive. I've seen plenty of interfaces that have been explored by people to deploy and press buttons. Who's going to run this type of failure?
For this platform, we didn't use Spinnaker. We thought it's not a great solution to open this to everyone. Ideally, we want this to be used by operations teams. And that's why we built a very simple custom user interface. As you can see in the image, the user can select the traffic shifting options, let's say using Istio, egress gateways, or DNS, depending on the mode. And they also have the option to do incremental traffic shifting, which is very similar to what we do with progressive deployment.
So we're building lots of solutions into our problems that we're facing as a company, as Expedia. As everyone knows, if you build lots of tools, not everyone's going to use them. So how do you start monitoring and tracking the usage of these products and services at Expedia?
It is important, even before building all these tools and platforms, to think about tracking adoption and usage. And for that, we need to expose the right data, which is what we did from the beginning. To give 2 examples of the 2 platforms, the chaos engineering platform, we know at any point of time how many experiments are running, even a breakdown per cluster, per region, per application, and so on. This is, of course, on top of any observability data that we use for monitoring. This is mostly for statistic purposes. And in progressive deployment, similar, we expose a lot of these metrics. We know how many successful deployments we do, how many rollbacks we have to do, and so on. So the question now is, we have built all these tools, all these platforms. They are nice. We are engineers. We enjoy building. But how can we accelerate adoption and usage of these platforms in a company of the size of Expedia, where we have thousands of engineers and hundreds of engineering teams?
Interesting question. So 29,000 applications, loads of engineers. You can build as much as you want. We can have all the metrics we need to track and monitor and see how the usage is, but it's very important to understand how to put a plan together to promote and advocate your software internally. There's a lot of discussions around how to advocate software externally, but there's always a key internal for your developers as well. And this leads to culture. Training is important. Training your engineers to understand how to use these tools and software pieces is important. And what we have in these domains is enablement teams. Enablement teams are very close to the domain, and they know the domain's weaknesses and strengths internally from a technical perspective. With these enablement teams, what we do is we actually provide them with bite-sized videos, workshops, and training strategies to help their engineers in those domains utilize the tools the right way. With that, we get case studies. Case studies are good. Case studies will allow other leaders to see the value that another domain is having from these products and services, and encourage their own domains to have the use case, the time and the roadmap time to actually utilize these products and services. This again comes with the case studies with the enablement teams, which is, as an engineer, utilizing a progressive deployment or a chaos engineering platform, my focus is to execute experiments, but not to look at the outcomes of the wins all the time, because I'm focusing on my feature delivery. So success stories become a thing which is a partnership with the engineers themselves to really pull out the key wins and the business outcomes from those tools that we're trying to provide. If we have good case studies, they get promoted to our blogs externally, because that's the actual value that we're getting from our business, and that's worth sharing with other business industries as well. So it's a little cycle there, like a feedback loop. Get the engineers engaged, have enablement teams, have success stories to share with everybody else, and put them into the blogs to share publicly with the team and internally as well. The other thing we can do is do game days, which is actually target specific areas of our domains. Working with enablement teams, really figure out where in the infrastructure, where in the actual systems design they can utilize, be it chaos engineering, as you mentioned, or progressive deployments, or failover as a service. So we're really looking at how to deconstruct their system from the outside in and break it as much as we can and provide them the support that they need. This again leads back to case studies, which is a success story for other domains. The other domains then catches on, and we end up with a kind of a success story in itself. So, as I mentioned, this was 2019. We're evolving. Week in, week out, Expedia evolves. New features, new products, new domains. How do we ensure that whatever we provide to our engineers, who I'm going to say are my customers, that they know where to go and how to find these things? Because Expedia is quite a big company. Where do we go?
And the reality is that a big issue in most big companies is where to find something. Let it be source code, let it be documentation, let it be tools. And the issue we saw here is that we have built all these platforms and tools. We even had plenty of guidelines in different places, but it was hard, even for us, not for engineering teams, to connect the dots around all these things. And what we did was we came up with this idea of the reliability hub. I think this exists already in other companies too. The purpose of the reliability hub is that it aims to provide good practices when it comes to building highly available systems and services. It also aims to raise awareness of the tools that exist inside the company. Again, it's a big company. We have hundreds of tools and platforms internally. And this is one of the goals of the hub. And we try to keep this hub practical. It is not, again, another set of guidelines, which engineers, they don't really like reading documentation and guidelines. So we try to keep this practical by tying this to implementation details. And this includes, let's say, I want to do circuit breaking in my application. How can I use the internal SDKs, the internal templates we have to implement that? We also try to implement as much as possible of those good practices into the platform, to bake them into the platform. Okay, yeah. And this was our journey here. As you can see in the timeline, we started early 2021, maybe a bit earlier. We identified any gaps we had in that space. We came all together with different brands, as we mentioned at the beginning, and we had plenty of tools. This meant consolidation, it meant reevaluation of licensed tools, open source tools, in-house tools. And then early 2021, we designed the new systems and the vision we had for those systems. We proceeded to the implementation late 2021, and after that to the integrations that we mentioned with continuous deployment platforms, developer hubs, and more. And now we are in this phase of adoption, which is a tough one most times. This does not mean that it is only about adoption for us. There's still a lot of engineering work that's happening. We might go back to these products and rethink about the implementation, rethink about the design even. Okay, so what are the key takeaways of this talk? The first one is try and drive reliability with tools and with data. We talked about the incident analysis that we did at the beginning. This was hugely beneficial for any investments we made in tools or in processes, because it allows you then to decide on the tools you want to build or even to prepare for incidents. Because after all, we build all these tools to reduce incidents and better prepare our engineers. And finally, make sure that you produce the right data, again, to be used for any of these decisions, for statistic purposes, for talking to different stakeholders or even the leadership.
Yeah, and the key takeaway for me is focus on the customers. And in this case, our customers were our developers. As platform engineers, we want to make sure we have that feedback loop in place to ensure that we get them on the right path. And this, as I mentioned before, the key thing here was to get them to a platform which would decouple them from the details of beneath the systems. So a paved road is a great example for that. If you have those ideas, then definitely kind of work towards those things. Integration is quite key for us. Many tools, many services, many UIs, many products, and if engineers are bouncing between these kind of tools and services, as platform engineers, we're trying to think about how to integrate those and have abstract layers between those so we can kind of decouple them as and when we want to, but it keeps the focus on the engineers on the delivery of their solutions and to production. Finally, bridging the gap between people, process, and technologies. Cannot stress this enough, where leadership has to understand what you're trying to build as platform engineers. The reason why we're trying to build this is to remove the instances from production, therefore reducing the risk within our systems, and improve the processes, which is make it as super simple as possible for engineers to get their software to production as fast and safe as possible. When you design those systems, always think about the customer and get the feedback. We've seen many times where we've built systems and we've just kind of handed it over to the engineers to say, go and figure out. It should be quite simple, read the manual, and they want to make sure that that does work, but you've got to provide that support, as I mentioned before, which is the workshops, the continued learning in that space as well. We're now open for any questions about A, our journey, and B, any of the products we're discussing as well, which might be a bit more detailed for what we do, but we're more than happy to ask any questions. Eric, over to you.
Awesome. Oh, we already got one. Perfect. Yeah, I don't even have to.
Thank you. Right, so my question is about breaking changes. With 25,000 microservices, you're bound to have a breaking change that break things. So how do you figure, like, did you develop some way of pointing a canary deployment of application A to a canary deployment of application B, so that you could have the breaking change of application A and the version that supports that breaking change of application B on the same canary deployment or something like that? How do you figure breaking changes?
Do you want to start?
The answer is we don't have anything for that.
Okay.
It is definitely a good idea, and over the years, I think we have talked a lot about that. In the past, we used to have a dependency graph. We are also building something similar right now, but we don't have a solution for figuring out whether dependency X is going to impact dependency Y.
Gotcha. Thank you.
Yeah.
Any other questions? Oh, yes, we got some hands. Awesome.
Thank you, amazing talk. It's really incredible the amount of tools that you two have been able to kind of bring to the company. I think it's really leading in the industry, the amount of support you're providing to your users. My question is about game days. Are you going to teams and being like, hey, we need to game day? Are they coming to you? Do you surprise them? What does that culture look like at your company?
I can take that one. I think you mentioned all three, and I think we do all three.
Oh, whoa, okay.
So sometimes it's a surprise to teams because depending on the maturity of the team, we might ask them for a game day, I'm going to say it nicely, whereby we will do analysis of the system, and then we'll take them to that place where they'll get to a game day. So it's not a complete surprise. We'll do surprise, game day, you want to chaos and experiment. Depending on word of mouth, as I mentioned, and the culture of the teams, people do come to our teams to ask for a game day. Recently, we did an AZ failure in production, which was someone came to us and said, can you execute a game day? Can you be on standby if anything goes wrong with the framework? We had full confidence in production. They ran the experiment, they created the pipeline, they pressed the button, we were there to watch, and that worked quite nicely. So it was a controlled game day where they came to us. And the other one is, we do have game days by natural when there's incidences. And what we do is we review the incidents thereafter and we verify if there is a opportunity for a playbook to be created, which we then kind of share with the wider community and say, hey, look, this domain had an incident. There is a capability that we can kind of run and execute for you. Do you want that capability? And we can schedule that in as well. So all three, I'd say.
Have you ever pissed someone off doing that?
I won't repeat what you said, but have we ever annoyed people? I think if you engage with people early up front, as I mentioned, that they know what they're prepared for. If the chaos experiment itself is matching a hypothesis that we want to execute, then every learning is an opportunity, I'd say. So for them to be annoyed that something's not worked as expected, that's a learning for us, which is another case study. There's been many case studies where we've done an experiment where there's been no actual win, which is perceived. However, that's resiliency working at its best. So a great game day is no problems, no troubles. Everyone's alert, everyone knows what's firing, everyone knows what's exactly happening, and there are wins as well. So pros and cons with the response of leadership or engineers, but it's a win-win for me, to be honest.
Thank you.
Since Kaushik mentioned about the confidence part, it took us time to build confidence in these platforms. It didn't happen in days or weeks or even months. Because at Expedia Group, we have been running chaos experiments in production with other tools, I don't know, probably since 2015 or so, yeah, in production. With the new tools, again, it took us a year and a half at least to productionize these platforms and have them running in production with confidence.
Hi. I had two questions. One with the adoption and the journey that you showed up. You started developing late in 2021 and then started to develop that entire 2022. But in that 2022 period, were they early adopters to try the product and get the initial feedback and then iterate on top of it? Or were you developing and then started showing adoption in 2023?
Yes, totally. We don't follow a waterfall model in any of the projects, so we constantly iterate. We had a very basic proof of concept in a quarter or so, less than 2 quarters. And since then, it was very low level. It was just this chaos controller Linux kernel level. But even at that point, we were rolling this out to certain customers, getting feedback and understanding their needs, which is how we started building any abstractions and integrations.
Got it. The second question is on the region failover as a service. Do you have apart from the manual intervention of doing it with the dashboard that you showed, were there any SLO-based region failover, like your error budget is burning out in next 1 hour for a service, and that service doesn't have a capacity in the specific region, then that the service takes care of region failoring and that's traffic automatically?
Just to kind of clarify the question, so the question was, do we have an automatic trigger for a failover?
Yeah, for the region failover of a service traffic, because that service doesn't have enough capacity to serve that traffic load in a specific region. So the trigger is to ensure that, okay, I don't have 50% capacity, but I'm getting more throughput.
Yeah.
And I have to fail over that to a specific region.
Sure. Just to answer the first part of the question, which is the automation of failover.
Yeah.
I think the dependency question that was asked earlier, which is failing over in an automated fashion requires maturity as an organization. I honestly don't think we're there right now, as I mentioned. So this is the reason why our operations teams will take care of the failover. From a capacity perspective, the failover service has the ability to kind of scale traffic up on the second regions. If the region itself, which is under duress, vertical scaling is an option or horizontal scaling is an option. If we hit horizontal scaling limits, then we have a bigger problem, which is potentially unwanted traffic on those clusters. Therefore, we'll probably look at other techniques to kind of mitigate that bad traffic. But I would expect HPAs to kick in, to be honest, on the region that's under kind of duress. Does that answer your question? Or we can take it offline afterwards as well? Yeah, sure. No problems.
So what's your tracking mechanism? How did you come up with that number of 75% of your incidents were caused by changes? With 25,000 microservices, how did you know which incident was caused by a change, and how did you track?
Yeah, sure. So a little bit of brute force, not going to lie to you, a little bit of manual work had to be done, which was to go through the incident processes. We have a process whereby when an incident happens, we track the change, we tag it with a theme, and then we kind of identify if there's any sub-themes to be followed up thereafter. Looking at the entire year, X amount of incidences, divide and conquer, everyone goes through, and we start tagging them that way. But that was a one-off exercise during that time, and that gave us additional themes for 2022 and 2023 beyond. So we try and do that every other year or so, just to make sure we're on track with our themes. We're getting better because we're now putting a bit of AI in there. I'm going to say the word, which I didn't want to say, which is our instant kind of channels are full of useful information, which someone has to go through. And if we had something to tokenize the kind of keywords we're looking for, then it makes it super simple. But in 2019, it was a lot of manual work, just to kind of analyze, get some SMEs on the subject to see which patterns there were, to give us a direction of which way to go.
Okay.
Any other questions? Oh, got another one. I won't throw it to you, put the copy down. There you go.
Can you hear me? So first of all, thank you for a great talk and making it look easy. I have to say that was impressive. One of the challenges is, to some extent, not a technological one, but in some sense a cultural one. Mm-hmm. I suppose to some extent, or to what extent would you say the specific technology choices that you made accounted for your success? And how did you navigate some of those barriers to adoption for things like Kubernetes, which can historically have convincing people to cross into that domain can be challenging, for example. How did you navigate some of those more cultural barriers?
Yeah, George. Shall I start?
I didn't get the entire question. So,
I think the question was, how do we encounter, or the technology choices we made, which ones were successful in terms of our choices from a cultural perspective for people to transition to the new technology choices?
Okay.
I can start while you're thinking.
I can try to rephrase that if necessary.
No, it's fine. He's thinking away, it's fine. Change is difficult for engineers when they're used to a way of a process, which is why I said your customer focus has to be critical, right? Technology choices sometimes come through from conferences, from talks and so forth. So engineers will pick up on certain technologies that they want to try, and they're your kind of catalysts. So they're willing to actually have a go and try things. The choice of technologies we made, Mesos was on the table, Nomad was on the table, Kubernetes was on the table. We weren't the team that was running the runtime platform, but we were building upon the platform. So there's a lot of discussion that takes place early on technology choices, and that involves a consensus of architecture, security, and so forth. So those conversations happen early on. When we make a change in technology, it's generally an opinion followed by a request for feedback. So there's a lot of feedback that people do give to that technology choice. Once people know that that change is happening, is how do we prepare for that change? How do we ensure that the engineers in that space can A, build the product and be kind of left alone to some extent to try out the actual POC? And as Nikos mentioned, even with the progressive deployment, we tried Flagger, we tried even other flavors of kind of canary products out there, just to see which technology choice is actually meeting our requirements. If they don't meet our requirements, then that's a discussion again, which is let's take it back to the table and say, hey, look, we had this idea, we had these technology choices, here's what's on the table, which one should we go with thereafter? So it's a cultural change to get people to shift, which is always a challenge, because sometimes that's part of the roadmap to get people onto those migration paths. And we have amazing program people to take care of those kind of program kind of pieces to get people to migrate and move. But from a technology perspective, it's always checking the requirements that you have as a choice of technology versus does it actually meet the actual outcomes of the business as well. Nikos, do you want anything to that?
Yeah, when it comes to technology, like decisions around the tech stack and how to implement these platforms, because this also applies to these platforms. One thing I personally found useful was, let's take the chaos engineering platform. You can implement all these failures in many different levels. You can call APIs from cloud providers. You can use Kubernetes APIs. You can do that at the Linux kernel level. And the decision we made was to keep that as agnostic as possible. And we were lucky because Datadog's Chaos Controller was implemented like that at the lowest possible level without relying on service meshes or on. It only relies on Kubernetes because it's an operator, but other than that, nothing else. And we had these discussions many times. Should we use Istio's capabilities for failure injection? But the question is how long we will be using Istio as a company, and what if that changes? While the lowest level, the operating system, is not going to change for maybe 10, 20 years. I mean, hopefully, but you never know. But this is why how many times we make these kind of decisions.